So, welcome students for the another video lectures on introductions to 3D printing technologies, the MDM course. Now, in this unit, in this video, we will discuss about the fourth unit, that is our materials for the 3D printing. So, we will start with the thermoplastics, the polylactic acid. So, PLA, it is a very popular the popular filament, the material is there. That is used for the fuse deposition modeling technology, that is FDM printers. So it is derived from the renewable sources like corn, starch, and sugarcane. Okay. PLE is also known for being environmental friendly and biodegradable. Okay. So it is or it is developed from the corn, starch, or sugarcane. Now, how this is prepared? So it is produced from the fermented plant starch, which is converted into the lactic acid. So this is sugarcane corn. Then it is converted to the lactic acid. Then after polymerization, it is converted into PLA. Okay. After polymerization, the PLA is then processed into pellets. Okay. The pellets are formed, and then so using the 3D the filament manufacturing machine, so it is converted into filament, and that filament it is used for the 3D printing. Okay. Mechanical properties are given here. Here thermal properties are very important because this temperature you have to specify in the 3D printing software. So the printing temperature is, sorry, this one. This is the printing temperature. So 180 to 210 20 degrees Celsius. That is mentioned on the PLA that spool also. Okay. So if you purchase PLA filament, so this temperature is mentioned on the spool. Okay. Then the applications are prototyping, educational and hobby projects, medical application, consumer goods, and packaging. So all the applications are here. Advantages are there, eco-friendly, because since this is prepared from the sugar corn or the sugar corn and sugarcane or corn. Uh, Sugarcane corn. So this is the biodegradable, ease of use, okay, aesthetic quality, and low order. Disadvantages are mechanical weakness, thermal limitations, and biodegradability the limitations. Cannot be used for preparing the medical parts. So that is the issue with the PLA. Then the second is called the ABS, that is acrylonitrile butadiene styrene. Okay, so that is the long form of the ABS. It is widely used thermoplastic polymer known for its strength, durability, and ease of processing. It is particularly popular in 3D printing due to its excellent mechanical properties and suitability for creating personal parts and prototypes. So, if you want a better strength instead of this PLA, we are going for this ABS material. Okay, so these are the ABS filaments. Now, how this ABS is formed? So it is produced from the polymerization of three monomers: acrylonitrile, butadiene, and styrene. So acrylonitrile, butadiene, and styrene. So they undergo polymerization process, and then they forms they form the pallet. The three monomers are polymerized together in varying proportion to create ABS with desired properties. Then the ABS is then processed into pallets, and then using the 3D printing the filament manufacturing machines, though the ABS filament is formed. Okay, so this is again formed similar to the PLA using the polymerization method, but here these are using the three monomers: acrylonitrile, butadiene, and styrene. Then these are the mechanical properties. The important parameter is printing temperature, that is mentioned on the spool of this ABS filament. If you purchase this filament, so that is again, and then the bed temperature. These two temperatures are mentioned there on the spool of this filament. Okay. Uh, then here it is insoluble in water, good chemical resistance. Okay. Uh, what are the applications? Functional prototypes, automotive parts, consumer goods, industrial application, aesthetic models. So wherever there we require a better strength in that particular applications, we are using the ABS. These are the advantages: strength and durability, heat resistance, finish quality, cost effective. Disadvantages are warping and shrinking. So tend to warp and shrink during the cooling. that is a order. It is emits a strong order environmental impact made from non-renewable petroleum-based resources, and it is not biodegradable. So PLA is it is generated from renewable and it is biodegradable, while ABS is not biodegradable. Requires more precise printing condition and can be challenging for beginners compared to PLA. So we require here closed environment for ABS. We don't require any closed environment for if we are using the PLA. Then the next the filament the material is what PETG. So this is called as polyethylene terephthalate glycol. It is modified version of this polyethylene terephthalate that include glycol to prevent crystallization, making it a popular choice for the printing due to its excellent combination of strength, flexibility, and ease of printing. So PETG is the another material that is used for 3D printing. Now, how this is formed? So this is formed produced by copolymerizing ethylene glycol and terephthalic acid with cyclohexane dimethanol. So this is the combination of the three chemicals. So copolymerizing ethylene glycol. So this is ethylene glycol, terephthalic acid with the cyclohexane dimethanol. So here again the process is there, the polymerization process. Okay, we have to form the pellets. Okay, so after forming the pellets, that pellets are used for in the filament making machines, and then it is extruded to form the filament. Okay, so now here again the printing temperature. So printing temperature and bed temperature, these are the important properties for this. For if you are using this filament, so you have to set this temperature for the in the extruded temperature and this temperature for the bed, the printer bed. The applications are the functional parts. The most important the properties of this PETG is what it is naturally transparent. So this is the most important property of this. That's why we can make the transparent object using this PETG. Okay, so mechanical components, consumer goods, prototypes, and medical devices. So having the property of transparent nature, it is naturally transparent, so that we can prepare the transparent parts using this PETG filament. Then these are the advantages: strength and flexibility, clarity. So clarity is very important. Ease of printing, food safe. Additional issues are there with this PETG. Stringing. What is the stringing? The phenomena. So stringing means what small strings of plastics are left behind on a 3D printed model. So when you are printing, so this type of the threads are there. This is what the stringing. And the another one is what the oozing. The another defect is what it is oozing. Oozing means what? When the extruder nozzle leaks the filament while printer is moving to a different position. So when the nozzle is moving to the another position, so filament get leaked. So that is called as the oozing. And stringing means what? The small string of plastics are left behind. So this type of two defects are there while using this PETG. UV sensitivity, not UV resistance. As some other material which can lead to the degradation over time when exposed to the sunlight. So these are the advantages and disadvantages of using the PETG. So polyethylene terephthalate glycol. Now this is very important. The material is there, that is for the polyvinyl alcohol. So generally, actually polyvinyl alcohol is a water soluble synthetic polymer commonly used as a support material. Okay. So initial, these are PLA, these ABS and PETG, these are used for build material, while polyvinyl alcohol, this is used for only to provide the support because it is water soluble. Okay, and it provides excellent support for the complex structures and overhangs, making it easier to print an intricate design that would be difficult to achieve with the traditional support material. Okay, so how this the PV is formed? So it is produced by polymerizing vinyl acetate monomer followed by hydrolysis to remove the acetate groups, yielding the polyvinyl alcohol. So vinyl acetate polymerization, polyvinyl acetate, polyvinyl alcohol. So we'll get this one. The pellets are formed after this, and then using the 3D printer, the filament making machine. So the filament is prepared for this PVA, polyvinyl alcohol. The most important property is water soluble. That's why this is used for particularly used for generating the support structure. Okay. Now once the applications are support structure, prototyping, and educational research. So since these are used for providing the supports, you can dissolve this into the water or any chemical, and this support material get dissolved into the water, and only the part get the part we will get the required part, and the supports get dissolved into the. This is made up of PBA, polyvinyl alcohol. So this get dissolved into the water. This get removed, and we'll get only the part. Okay. These are the advantage. The most important advantage is water solubility, compatibility, easy of use. It is disadvantage is moisture sensitivity, mechanical weakness, and printability challenge. So we can use only for this making the for support structures here. So that is a disadvantage for this. The printability challenges are there with while using this PBA, polyvinyl alcohol. Now these are the what we have seen here earlier. So these are all thermoplastics. Okay. So in thermoplastics we have seen the PLA, polylactic acid, which is biodegradable, formed by polymerization of sugarcane and corn. Then we have seen the ABS, which is formed by the polymerization of three monomers, acrylchloronitride, butadiene, and styrene. Then we have seen the PETG, which is formed from the ethylene glycol and terephthalic acid along with the cyclohexane dimethanol. Okay, and finally, so in PETG, the most important property is naturally transparent. And then we have seen the PBA, polyvinyl alcohol, which is water soluble and act as a support structure used for generating supports supports along with the build material. Now we will shift to this the metals. Okay.